even. Odd and even. It has nothing to do with 1 and 2 or 3 or 4. It's a totally different concept. And you could say odd and even what? And I'm going to say odd and even functions, of course. We're talking about functions. Okay, I'm going to move to the next page because I need to graph something and I want to make a table. So odd and even. Of course, functions. Okay, so let's start with this side. Does anyone remember how to graph f of x equals x squared? We're going to graph it again in chapter 3, but it's a parabola. And the vertex is where? 0, 0. Very good. Awesome. So this is the graph of x squared. So now here's a question for you. Let's say I draw a horizontal line. And I create 2 points. Here's one, and here's the other. If I denote this point by x, what do you think this point will be?
Negative.
How much?
Like the negative x.
Exactly. Perfect. Awesome. Now, this is function f of x as well as x squared, right? Can anyone give us the coordinate of this point?
Negative x squared, comma.
So I would like the coordinates of this point. Let's call it point A. What is the x coordinate of this point? Very good. What is the y coordinate of this point?
1.
I did not say what the horizontal line was. Exactly. Y. Is there another way of writing y? Careful. The x is not f of x. The x is negative x. You're on the right track. So what would be the y coordinate then? F of this x. If this is 5, I cannot say f of 15, right? So if this is negative x, then the y coordinate must be f of negative x. Very good. So let me write it one more time because it's kind of small. So point A has coordinates negative x, comma, f of negative x.
Why is it negative x?
Because that's what we picked. So if this is x, this must be negative x. If this is 5, this is negative 5. So if this is negative 5, this must be f of negative 5. So whatever x is of the point, then I have to find the y by plugging it in, right? So if this is negative 10, then this is f of negative 10. In general, if this is negative x, then this must be f of negative x. Agreed?
Yeah.
Good. So now let's look at the other point on the other side. And let's say this is point B. Can anyone give us the coordinates of point B? Perfect. Of course. It has to be. So this point is here, right? So this is the x and this is the y. This height is f of negative x. This height is f of x. What is the relationship between f of x, negative x and f of x for such a function? Of course, they have to be the same. This function is called even. If f of negative x equals f of x, the function is called even. And can anyone tell us what is it symmetric with respect to? So we can see the graph very clearly. It's symmetric if the function is even and f of negative x, f of negative 5 equals f of 5. The function is even and its graph must be symmetric with respect to Symmetric with respect to
The y-axis.
the y-axis. See, I could have not done that with the board, right? So, symmetric WRT with respect to the y-axis. All even functions are symmetric with respect to the y-axis. And please remember the relationship. F of negative x must equal f of x. For any even function, symmetric WRT with respect to the y-axis. So that's one option. There is only one more. Here's the second option. Any questions on this? Okay, perfect. Let's look at the other option. I'm not going to ask you this function because we're going to talk about it extensively in chapter 3, and I don't think you graphed it before. So that's okay. Notice that the graph does not cross the x-axis like this. It crosses slowly. We're going to talk about that in chapter 3 as well. Okay, ready? I'm going to create a point here, which I'm going to call A. I'm going to connect this point to the origin with a straight line. And of course, I'm going to create on the other side what? Point B, of course. So let's look at point B. And please tell me the coordinates of point B if this is x and this is, of course. So one more time, coordinates of point B, x comma f of x. Excellent. But now if this is x, what do you think this one on the other side will be? Very good. And now careful, give me this height right here. What will this be? So we can determine the coordinates of point A. Negative x, comma, f of negative x for now. Very good. So if this is negative x here, this one will be f of negative x. If this is x, this here will be f of x. Now I would like you to discover for me the relationship between f of x, f of negative x, and f of x. Obviously, they cannot be equal. They were equal here, f of negative x and f of x. But what is the relationship now between f of x and f of negative x? And they cannot be equal. Opposites. Opposite. So how do I write? F of negative x must equal negative f of x. And the function is symmetric with respect to, if a function is symmetric with respect to the x-axis, it's not a function. So there are two symmetries. One with symmetric with respect to the y-axis, and the second one with respect to the origin. Symmetric with respect to the origin. So now we can go back to our previous graph in 90 something, 52, correct? And finish up those two parts. If the function is even, odd, or none of the, yes, Brianna had a question. Or if f of 2 is a relative maximum. So they consider that no. So now let's look at the graph again. And establish whether this function is odd, even, or none of the above. Don't forget, I hit it intentionally. There is a point here and there is no point on the other side. So is this function, I tricked you, sorry about that. So is this function symmetric, odd, even, or none of the above? None of the above. So please write none of the above. The function is not symmetric. Sorry about that. so I'll go back. So for L, no relative max or min. And for K, not symmetric. For the same 52, problem 52 from before, I promised to come back and finish it up. So K, the function is not symmetric. And in L, the function does not have a relative max or a relative min. Any questions so far?
So because of the last question, it was it ended with a little dot. That's called it was closed.
Yes, it's a full point.
Okay. That's why.
The function is not symmetric. It has to be completely the same on the left-hand side and on the right-hand side. It's not the same. The function is like this.
If it was the same though.
If it were the same, I would have said yes. If it had arrows on both sides, I would have said it's symmetric with respect to the y-axis. Because it had -2 and +2, everything was symmetric.
Okay, but you asked if it was negative or positive or oh sorry, odd or even. If they were the same, like would it be odd or even?
It would be even, symmetric with respect to the y-axis.
Okay.
Yes, but it stops here and it continues here, so it cannot be symmetric. Right. Okay. Any questions? Any questions? Okay. I want to finish today with a major topic from the same section. We are still in 2.2. It's called piecewise defined functions. Say it again. Any questions for me, please? Any questions? Bless you.
So the actual multiple is the exam because the exam going to have is going to be all the way everything that we just covered.
Do you have the syllabus?
Not with me.
Okay, at the end of the syllabus, it says exactly what sections each test covers.
You said it was like the beginning until 5, I think is what she had said.
2.5.
Yeah.
Yes. No, just I'm pointing that out just in case you have any questions or doubts when I'm not here. So at the end of the syllabus, the schedule, it includes everything, including 2.5. Okay, so piecewise defined functions. The function is given to us in pieces. I'm going to copy one. Let's say, for example, problem 64. I'm going to modify it a little bit. So let's say x plus 2, negative 2 to 52. I'm modifying it, so it's not exactly the same. Negative 2x plus 4 for x less than negative 3, and for x greater than or equal to negative 3. Okay, this function is called piecewise defined because it's defined in 2 branches. Do we know anything? Do we have an example from real life situation that will be modeled by a piecewise defined function? Here's an example. I don't know what happened this year. I haven't done my taxes yet, so I don't know what the situation is, but I'm just telling you from the past. For example, if somebody made from 0, I'm throwing numbers at you, I don't know the exact numbers. So let's say between 0 and $30,000, the person would pay 10% in taxes. Between $30,000 and $50,000, the person would pay 12% in taxes. And this is piecewise. For this interval, a certain formula. For this interval, a different formula. For this interval, a different formula. That's a typical piecewise defined function. Okay. Also, the post office uses a piecewise defined function. For a parcel or a letter between this and this amount, we pay $1. Between this and this, $1.25. Between this and this, $1.50. That's a piecewise defined function. I don't have the exact numbers. Okay, so here we are asked to do 2 things. We're asked to graph it and find its range. Okay, so every time I'm asked to graph a function, the first thought I have is to find the domain. That is absolutely mandatory. That's my first step. We will always do this for moving forward to functions in chapter 3, functions in chapter 4. First step, domain. Why? In other words, I don't even know what x values to plug in if I don't find the domain first. Okay, so first I'm looking at this interval, and I'll say I can replace this. Don't erase it like that. I'm just making a point. I can replace it by this. Do you agree with my replacement? And I know you're going to say why, and I am going to explain why. But you agree with the replacement. You don't know the reason why, but I will tell you in a minute. I will also replace this by, what do you think? Very good, -3 to infinity. So now let's look at these two intervals and guess. There is no guess. It's scientific. What is the domain of this function? Correct, absolutely. That's when I start my table and put -infinity to infinity and put f of x. Now, you understand that there are two branches and they will never overlap. The first branch has its own territory. The second branch has its own territory. It's like somebody making $20,000 a year cannot pay 10% and also 12% in taxes. It's one or the other. Okay, the next step is I see that there is a key x value. What is the key x value that I have to have in the table, even if I want it or not? Why? Excellent. And why? Because something happens at -3. This is like a threshold. I go from one function to another at -3. So that's why -3 has a very important x value. Good. Now I see that there are two different things happening at -3. A parenthesis facing this way and a bracket facing the other, and they are touching each other right immediately under -3. The next step, I am going to ask you, which function do I use for this and which function do I use for these x values? And you can say, it's already there. Why do you want me to write it again? Bear with me and write it again. So for x values between -3 and negative infinity and -3, I will be using which function? X plus 2. Between -3 and infinity, I will be using which function? I know it's a silly question. It's the other one, right? -2x plus 4. What type of functions are these? The degree will tell us what type of functions are they. What is the degree? 1. So then what can they be? Can anyone tell us the degree of x plus 2 as a polynomial? So what type of function will that be? Cubic, square root, absolute value, rational, exactly linear, of course. That's a linear function. We know this since like forever. What type of function is this? Also linear. So I need 2 points for each. Good. So I'm going to plug in -2. Can anyone tell me why I picked -2 and not -3? Because I get the x-intercept correct. Okay, let's plug in -3. What do I get? -3 plus 2 is? Good. Notice that I put it inside the parenthesis, and I was expecting for you to say, wait a minute, you're not allowed to plug in -3. I'm not allowed to plug in -3 in the first one. -3 is here. -3 is over there, so bear with me. On the other side, please. So let's plug in -3. What do we get?
I don't understand anything right now.
By plugging in -3, -3 plus 2 is -1. -2 plus 2 is 0. Right? So it's -3 in here. -3 times -2 is... Yes, of course. Yeah, well, I'm finding y values. Yeah. So -3 is 6 plus 4 is... Good. Let's plug in 0. I just need 2 points on both sides. That's why I asked what type of function it is. It's linear, I need 2 points. So let's graph. I have to pick these values and 2 more. 1 on this side because they're linear. So from left to right, what is the first point that I have to plot? From left to right, the first 2, comma 0. Very good. What is the next one?
So -3.
Excellent. -3, -1. What type of point is this?
Maybe.
Is it a full point? Is it an open point? Exactly. This is an open point.
Is it just not those, it's just because of the parentheses?
Yes.
Yes, that's exactly why I use the parenthesis to indicate that this is an open point. So -2 is 0 and -3 is -1. But so -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -3, 10. That is a full point. And at 0, when x is 0, y is 4. So -3, 0, and this is a full point. And on this side, at -3, sorry, -2 is not there. -2 is on this side. That's why I wasn't getting, it made no sense. So -2 is on this side, forgive me. So -4, so this is -2. Okay. So -4, comma, -4, comma, -2. My apologies, this is not a point. Yep, I'm trying to finish it before letting you go. So my apologies, this is not a point. Let's erase this one. So this is the function. Can anyone give us the range? Yes. Can anyone give us the range?
-10.
Exactly. The range is -10.